Good morning, class. Um, Today is the lesson 7 of calculus. Lesson 6, we did the opposite of this one. If you differentiate, um, if you differentiate sine x, you'll be able to get cos x. And if you differentiate cos x, you'll be able to get minus sine x. So this is what we want to prove. In lesson 6, we proved that if you differentiate sine x, you will get cos x. And today we want to show that if the function is cos x and you differentiate it, you should be able to get this one. So in other words, the derivative of cos x is minus sine x. That is what we want to show. Okay. So we are given a function as y equal to cos x. The first thing we do is to make sure that y is replaced by y plus delta y. And the same thing goes to x as x plus delta x. The first thing we do is to make sure that we replace y with what? Y plus delta y. And x is what? X plus delta x. What this one is trying to talk about? This one in real life. So we are trying to say that if you have like 10 and this 10 you add 0.0000, something like this. So this is like just 10. Yeah. So in other words, delta x is a very small number, very, very small number, in such a way that it is almost 0. That is why in calculus we say delta x approaches 0. Delta x tends to 0. So when we mean by delta x tends to 0 or delta x approaches 0, in fact, tends is like a purely mathematics term, but the one that is open is that delta x approaches 0, meaning very close to 0. If you have 10 and your friend decides to give you 0.009, so it's like your friend just gives you like nothing. So it means it is like it doesn't change anything. So if we have y and we add a very small amount of y to y, it is the same as just y. Yeah, in calculus, in mathematics, you have x. With this x you have, someone gives you another value of x, but it is very small, which is almost 0, which approaches 0. So we can say it is the same. So don't think that y x alone can be the same as x plus delta x. This is mathematics. Okay, so what we do now is that we subtract both sides from, we subtract y from both sides. Here we subtract y, here we subtract y. So we say y plus delta y minus y. Here again, cos of x plus delta x minus y. So y takes away y. So we are left with delta y. So this is cos of x plus delta x minus y. But originally, what is y? Cos x. Cos x. So the next thing we do here is that what is actually cos of this one? From compound angles, we understand that cos of the sum of two angles is equal to cos A cos B. You need to exhaust cos before you consider sine. Then you change this sign. Minus sine A, sine B. So when you want to find the compound angles for the sum of compound angles for cos, you exhaust cos before you consider sine. Unlike sine, where in the beginning is sine, the end is sine. But do not forget the order of the angles is still maintained. AB, AB, AB. Okay, for cos, plus attract minus, minus attract plus. Unlike for sine, wherein you maintain. Okay, so if this is true, then we can say delta y is equal to, now look at it, let's compare. Cos of A plus B, look at it, cos of A plus B, let us exhaust cos first. we say cos A, cos B. Then we change the sign minus. Now we'll go for sine. We say sine A, sine B. Then now we can say minus cos x. So we say delta x is equal to, we have three terms here. 1, 2, 3. This, we don't have it here, so we cannot pair them. But this one contains this cos. So this and this can be paired. So we say cos x, cos delta x, we'll bring this one, minus cos x, minus sine x, sine delta x. So we say delta x is equal to, delta y. Delta y, okay, is equal to cos. This is common, so we say cos x. We factor out cos. Cos x takes away this, leaving cos delta x minus this into this is 1. Then we have minus sine x, sine of delta x. So now what do? Let us divide both sides by delta x. So here we say delta x. Okay, so this is now what we have. Okay, so what do? Let us take limits on both sides. So if we take limits, so we have to say what? The limits, but in that case, once we take limit, this one becomes total derivative. So we say dy dx. So on this side now, we can take the limit and say the limit as delta x approaches 0. You see, it's because of this fact, using the first principle, it is owing to the fact that whenever you have any amount and a similar amount is given to you, which is very, very small, it's like nothing is given to you. Why? Because that amount is so small that it approaches 0. Okay, so now what do we have here? Cos x multiplied by cos of delta x minus 1 minus then sine x, then sine delta x, sine delta over delta x. Okay, but when I did the sixth lesson where we derived the derivative of what sine x to be cos x, you realize that I did little of delta x because I converted delta x to h. So we can also do the same. Let us replace delta x to be represented by h. So now we say, okay, dy dx is equal to the limit delta. Let us use the h tends to 0. Okay, so what do we do here now? Okay, let me write the same thing. Now we say cos x into cos h. Do not forget, you can maintain delta x to the end, no problem. Minus 1 minus sine x sine h over h. We've agreed delta x to be h. Yeah, so we don't struggle when we write. Some people are not conversant with writing delta. Okay, so now let us use one fact in fractions that says if x plus y is equal to 2, we can say x over 2 plus y over 2. Likewise, 3 minus x over 5, we can say 3 over 5 minus x over 5. So this is the concept we want to use now. So we can say dy over dx. Now the limit takes this minus the limit takes this one. Yeah, so But this cos x does not contain h, so it will be written outside, saying cos x times the limit of this one now, cos h minus 1 over what? Over h. Yeah, just like what I explained in fractions. Here is minus. Then again, we say limit. Now, this limit, we say h tends to 0. Sine x, no h. So let us write this one before the limit. Just as we wrote this one cos before the limit, because cos x, and here is h. So we say sine x, then I will say the limit of what? Sine h over h. You see, this over h, this over h. Don't forget, as h approaches 0, h approaches what? 0. H approaching 0 is the same as what? H tends to 0. Now, don't forget, in terms of limit, whenever the cos of a value here, angle, minus 1 over the same thing, this h is here, delta x is here, delta x. The limit of this one minus 1 over this is always 0. So in that case, we say cos x, this one is 0. Do not forget what I'm saying. In limit, the limit of cos of delta x minus 1 over delta x, as delta x tends to 0, approaches 0, is 0. So here again, minus sine x. The limit of any of this one, h delta x, over the same thing is 1, as long as what? H approaches 0. So this will give us 1. So 0 multiplied by any value is 0. So we are left with minus. Any value multiplied by 1 is the value itself. So sine x. So this tells you that the derivative of cos x is what? Is minus sine x. This is first principle. So thank you for watching. Don't forget to follow, like, share, and comment. See my next video. The next video we are going to deal with other cases, tan, cosec, and rest of them. Bye bye.